So let's talk about the factors that affect the rate of photosynthesis. So photosynthesis is using the light's energy to create glucose. The reason why it's so sunny is because I'm in Colombia at the moment, not my traditional where I used to do my videos in London. So, it's a very interesting story, but here is a very great place to grow crops. But sunlight isn't the only thing that affects how quickly you could photosynthesize, how quickly you could grow crops. Another thing is the carbon dioxide in the air. If we increase the carbon dioxide, we could increase the rate of photosynthesis. Another factor that we do in GCSE and IGCSE is also the temperature. Just like human beings, we have enzymes inside us that are doing a wide range of functions. Now, I'm going to draw a enzyme over here, and these enzymes help with photosynthesis, actually doing the photosynthesis. Now, a part of the enzyme I want to show you is this section right over here. There should have been a bit of a thicker highlighter. But this section right over there, we call it the active site. Now, if you remember, a substrate fits into the active site. The substrate could be carbon dioxide, for example, that will be split up and give us oxygen and carbon. The carbon, hydrogen, and oxygen can be used to make glucose. We don't want to get into much too detail. But if we just think about this, that this is the active site and something needs to fit into the active site and then photosynthesis, voila, happens. Okay, that is what we need to think about. But go back to physics. You need some energy to get this into the active site. You need some kinetic energy. Now, there's a relationship between temperature and kinetic energy. Back to physics, okay? So at a low temperature, the rate at which the substrate fits into the probability, I could say, of the substrate getting into the active site is going to be low. As we increase the temperature, it's getting easier because now this is becoming more energetic and this is becoming, and they're actually doing their actual function. However, if the temperature gets too much, what ends up happening is the enzyme loses its active site. It becomes what we call denatured. So this active site might end up looking crooked. And the problem is the substrate no longer could fit inside that active site. So if the temperature is too much, you could actually denature the enzymes that are helping the rate of photosynthesis. So enzymes' reactions are actually temperature sensitive. They don't like it too cold and they don't like it too hot. This is why we have a big problem with climate change, because climate change is making certain regions colder where the enzymes for those plants are not used to it, or making it hotter where the enzymes are not used to it. So this is causing a bit of problems. So I'm going to draw a graph, rate of photosynthesis, how quickly you produce the oxygen and glucose, and light intensity. So what we expect to see is as the light intensity rate increases, so does our rate of photosynthesis. Okay, great. But it's actually going to end up flattening out eventually. Why? Because now we've reached a limiting factor. And the limiting factor is, light intensity is not the only thing that matters. You also need to increase the carbon dioxide levels. So if the carbon dioxide levels is not high, the rate of photosynthesis is just going to level out. It doesn't matter how much light intensity. You cannot increase the rate of photosynthesis with just light. Okay? Congratulations, you got a lot of light. If I said, for example, this is at 20 degrees and the carbon dioxide levels, let's say, is 0.04%, what I need to do if I want to increase the rate of photosynthesis is to increase the amount of carbon dioxide. So I could keep the temperature the same, 20 degrees, and increase the carbon dioxide levels to 0.05%, for example. Now, the limiting factor is the temperature. I've got a lot of light intensity. I've got also, quite a lot of carbon dioxide. After going 0.05, it's not going to make much of a difference. So what I need to do is I need to increase something else. So what I'm going to increase is, instead of going at 20 degrees, I'll go at 30 degrees. So at 30 degrees, it will look like that. I'll keep my carbon dioxide levels the same. And now something else is the limiting factor. It could be the nutrients, it could be something else, but now you get the gist of it.